asked me that. There is no study guide for the quiz.
Yeah, and then so just keep doing that, and then make it like a little more circular, like up and down.
All right, here we go. There is no study guide for the quiz. It's a quiz. You've got notes. You've got all kinds of other things. You're not going to get a study guide for every single assessment. We're not going to review for an entire day for a quiz. Shh. What's a discontinuity? A line that has a stop. Gentlemen. Sure. Forget the white goal. What? A hole? Or there's a hole? Simplify, please. Simplify, please. Hole. You know, I technically don't need parentheses around the x minus 4. I just put them in because I'm used to it. Be a hole. Can you please simplify? Without holes and all kinds of other things that you're going to be putting places that whatever. So much easier. So much easier if you just get rid of the negative 4. So you get x squared x minus 3. Yeah. There are purpose. Make sure that you understand. That is so voodoo. Reduce polynomials. That is not allowed. So let's go back and do it the real way. Do I have x minus 4? Is that what I had in the denominator? Okay, so what do I do first? Factor. Yeah. Plus 1 minus 4, is that right? Over x minus 4. Now what? Reduce. Operation. So let's move on. Let's move on from the awful reduce, because what's x minus 4 over x minus 4? 1. I asked you to simplify. We are not graphing anything yet, okay? We're not, let's do a review problem with factoring. To the quiz as well as, oh no, where's my bookmark? I lost Portia. Oh, yep, there she is. Okay, good. I would make it up, but if I make it up, it's going to be nasty. So give me an opportunity to find one for you that's not so nasty. Oh, my Lord. Here we go. Are you still trying to teach her? The fourth minus 7x cubed. Let's make sure I write it down right. Plus 18x squared. Minus. All right, so you've done this before. This is a good example. Excuse me. take you a minute or two. Factor, factor, factor. How many factors should there be? 4. They might be real. They might be imaginary. They might be rational. They might be irrational. That's your job to figure out. Do you need less? Well, if you're stuck right now, make a note to yourself. I need to review this between now and tomorrow. Oh, that's smart. Me and Gavin are splitting up the work. You try this, I'll try that. Be loud. Thank you. Okay. Sir, Mommy, you need to ditch us. Oh, not yet.
Wait,
Bro.
today?
I don't know. Soon.
Wait, they got the day wrong, I think. It's tomorrow, right?
It says the 16th.
No, I know because,
Check.
maybe my mom said.
It's at the end. Focus. What? Fractional. Fractions.
Definitely not today.
Okay.
Should I go tell them, or?
Why don't you go? Yeah, you know what? Why don't you go tell them? Clear up misunderstandings. Routine, how do you start? Ask Emma. Review this for tomorrow. This is not a mathematical operation. You need more time? Yes, okay.
Hold on.
30 more seconds.
I did something wrong. Okay, what do you got? If you got stopped as better, but it's not good.
Mm-hmm.
I have x
You sure it's x minus 2 cubed, Kevin? Yeah, it is. Yes, it is. How do you start? P over Q. Q. Lead coefficient. P over the factors of Q plus or minus. Factors of P over the factors of Q. Plus or minus. What do you got for me? Now, how about what are the factors of A? 1. Thank you, Brendan. What are the factors of Q? Makes it much nicer. No fractions involved. So if Q was, 12, you'd have a long list. But luckily, Q is 1, so in this case, all right. So Tommy, where did you start? You started with 2, you didn't start with 1. How did you know 1 wouldn't work? You just simply look at the coefficients and the constants. 7 is negative 6 plus 8 minus 20 is negative 8 plus 8, I believe. Did you have to start with 1? You can plug in 1 without having to do synthetic? Sure. Brandon. Yeah, now I have to do the whole thing. But if synthetic. Because what's 1 to the 4th? 1. All you're left with is the coefficient. What's 1 cubed? 1. All you're left with is the coefficient. What's 1 squared? 1. All you're left with is the coefficient. And that's 1. All you're left with is coefficient. Saves you time, especially when you're taking the quiz, the test, whatever, and I say, okay, you have 5 minutes left. You have to learn how to save yourself. Bring down the 1. 1, 1, negative 6, negative 6, 12, 12, negative 8, 8, 0. You know it works because the remainder is 0. So how many factors have you just found? Okay, so keep in mind I said 1 is a 0. That's going to come into play. 1, agreed? Okay, so as a factor, how do you write that? X minus 1. How many are left? 3. They might be real, they might be imaginary, they might be rational, they might be irrational, but if they're rational, P is not a choice. It's not on the P over Q list. 6, not a choice. Not on the P over Q list. It is possible that none of these work. Let's hope they work. So, polynomial. How do you? Try grouping it before you even do anything more. Try grouping it. If you can group it, you're done. Grouping is a fantastic method of factoring. I don't think it's groupable. Groupable? I don't think so. All right, so now what should I try? What number, Elliot? Okay, so Elliot tried 2. Is it possible that 1 can work again? Yeah, it could work again. Okay, so it has been recommended that I try 2. I'm assuming. Yes, I'm assuming it works. 2 is a 0 of the function. So what's the factor? Perfect. X minus 2. You're down to a quadratic now. When you get down to a quadratic, do regular old factoring. Don't bother down to the factor it. Like, how'd I get what? Everything's factorable. Do the quadratic formula and work factorable. What's going on? Elliot, Brandon, are we good? Question? Perfect square trinomial. Perfect square trinomial? What are the remaining zeros? So we factored it, we got here. What are the remaining zeros? those are the factors, x minus 2, x minus 2. What are the zeros? 2 and 2. How's that going to change my graph? Yeah, it's got different multiplicities, so you have to be careful. This changes the graph with the bouncing and crossing, etc. Sort of. Yeah, Elliot. You got it. So this as x minus 1. You have an x minus 2 here. That's 1. You have 2 more here for a total of 3. Okay, so polynomial in factored form. Okay, so these are the factors. Now, what if I ask you to solve? So now, what if the problem I give you is equals x to the 4th minus 7x cubed plus 18x squared minus 20. So now what if I ask you to solve it? Zeros, intercepts, solutions. Solve the zeros, the intercepts, the solutions. And I believe I said 1 is a 0 of the function. Or is it? 2 is a 0 of the function. Yes. What are the zeros of this function? 1 and 2 and 2 and 2. How do you know that? So if this is the beginning of the problem, I'm not going to write. Where do you start? Yeah, well, this is the problem right here. You don't know any of the zeros. Where do you start? Factor it. How? Synthetic. Where do those numbers come from? P over Q. This is exactly what we've just done, only we're going to write our answers as ordered pairs. So we had, what did we have? 1, 0, 2, 0, with a multiplicity of 3. So how do you solve this? You start by factoring it. How do you factor it? You use synthetic division. Where do the numbers come from? They come from P over quadratic formula. So if you, well, hold on. Let's graph it first, and then I'll do that. I'm not saying it's wrong. I'm saying you're missing a pretty important piece of it. There you go. Do I know where it is? Nope. But I need to know that it's positive. You know the zeros, you know the multiplicity. There's 2 things you're missing. A, which tells you end behavior. You know the zeros and their multiplicity behavior, and you are accept. I care that it's positive or it's negative. Plugging in 0 and not important, at least right now. Overall degree, 4. I mean, I gave you the whole polynomial. There's the overall degree. It's 4. Is that even or odd? Even. What's A? Positive. Greater than 0. End behavior. Up, up. Fantastic. 1, 0, 2. Oh, this is kind of on top of each other. positive. That's half. Cross bounce, what's going on? Y. Check the Y. Well, you should. I've been pretty, like I just said, 2 minutes ago, I didn't really care. 8 is doable, so my graph's going to look really bad. No, listen, how can I adjust it? That works! I want increments. Oh, all right, so I want to go back. Polynomial, whatever, and you have to say, I give you, you can feel, but go ahead. Elliot, because if it's not going to have rational solutions. It would be factorable if the 0 was 2/5. Yeah? Sorry. No, not square root of negative 31. A, the lead coefficient. A is 1. Last semester. All from last semester. I gave you, it was the first page of the exam. It was number 3, number 4. The first page. And I gave you 2 solutions. X equals plus or minus, or 2 plus or minus I root 7 over 3, and you had to write the quadratic. Last semester. All right, so what does X equal? I root 31. Okay. Quadratic. The quadratic. That's that. We used the quadratic. How many? 2. You can factor it. We factor to solve. The problem I just erased, the first problem we did. You factor. Well, you factor. We're just kind of lazy. I can write this as fact. X equals 1, so it was x minus 1, and then 2. Yeah? Okay, great. So, kind of is. Move it. Subtract 3. Subtract I root 31. Subtract 3. 31. So, technically it is not form. If one, what would you do? X because wait, because did the quadratic. Okay, do it. Multiply it out. We're gonna wait for you. Write it down. Do the box. Jason, either do the distributing or do the box. You don't have a choice. Do the distributing or do the box, and let us know how it works out. How many times do I have to say? Now we're going to grab. Do you remember semester? Of course not. You have forgotten everything from last semester. October, I gave you a gold piece of paper with 6 parent functions on it. Find it. There we go. Steven's got it. And there is, on the back, there's some writing. There we go. Excellent, excellent. There's some domain. There's some range. That's something for science. Division by 0 on yours somewhere. Supposed to divide by 0. Let's start with x plus 3. So on that gold sheet of paper, right, we've been talking, the gold sheet, we have been talking about rational numbers for quite a while. P over Q, it's all rational, blah, blah, blah. This is rational. You guys are like these holes. What do we get? I mean, why is it rational? It's a fraction, and this one's even the denominator. Fraction with a variable in the denominator. Variables in the denominator, issues, issues, issues. What number, what value of x causes us problems? 3. If you plug in 3, the function is considered undefined. And that's the asymptote. Can't divide by 0. The function's undefined. What did I say about undefined? It's an asymptote. Undefined function shows up as an asymptote on the graph. So if x is 3, the function is undefined, therefore x equals 3 asymptote. We'll talk about horizontal asymptotes in a little bit. Yes, I know that. Like, you're going to just be so excited waiting to hear about horizontal asymptote. There are it's a line that the graph approaches, but never. So we're going to graph this. We're going to start with okay. So continuity. Nice flow. Draw that in one full swoop. I am close. Things to find. No, not at 2, but there is a horizontal. Okay, let's find the y-intercept. Pretty easy to find. How do you find the y-intercept of any function? Right. Y-intercept. If you make x 0, you get, yeah, so negative 4/3. Make x 0. No exception to that rule. So 0, negative 4/3. Okay, let's find the x-intercept. There might be more than one, right? The whole bouncing x-intercepts, there might be more than one. I think I showed you s in parentheses because there might be more than one. How do you find the x-intercept? Make y 0. Fantastic. Don't tell me to cross multiply. It is not a proper mathematical operation. You multiply both sides by -3. So you get +4. Yes? What's the x-intercept? -4. So in this case, there's only one. In this case, there's only one. What is the multiplicity? 1. 1 is, so it would bounce across. Yeah, that also. What's the shortcut? How do you find the x-intercept? All of this multiply. No? Close. J. The numerator. Make the numerator 0. So rational function has a variable in the denominator. Some function. And it has some denominator. If it's rational, it has to be a fraction. Yes, Evelyn. Because it only occurs once. That's odd. Odd crosses. I have some function, numerator over denominator. Do we agree? Great. I want to find the x-intercept. What do? You set the y equals 0. Right, Matt? Matthew's all. Okay. F of x is to make that 0. Agreed? So multiply both sides by d. Multiply both sides by the denominator. And you get the numerator. You just made your debut. Tommy. Anyway, so if you want to find the x-intercepts, make the numerator 0. Always works. You're going to memorize it. You don't need to. Think about it conceptually. What's the graph look like? So, Brandon, you are right about all those things, but you're about 8 steps ahead. So when we get there, I'll... No. No. That's not what we need to do. So we don't worry about end behavior until we talk about horizontal asymptotes. Oh my God, there's a horizontal asymptote. Yes, there is. By the way, it might be diagonal and it might be something totally. And draw your little graph. have it at horizontal asymptote. How am I going to find the horizontal asymptote? So Brandon said about end behavior. End behavior. Do you remember when we did this whole like as x approaches infinity, y approaches whatever it was going to do, and x approaches negative infinity, and y was going to do whatever it was going to do. Remember that? And then we determined that it was like up, up, or it was down, up, or it was down, down. I don't know, last week, maybe. Should be in your notes. Look back. Look back. Familiarize yourself with this. Look back. Familiarize yourself with it. Because this is like a ton of information on these graphs, and this is like the most basic that they get. We're going to do triple asymptotes with bouncing and crossing and everything else. So look back at your end behavior. How up, up, down, down. Your quiz. No. Yeah, did you? And when you divide it all out? Because you... Oh, you don't get it equal. Evelyn, you had a question. So, did you look here? So what I want to know is, as x approaches infinity, what's happening to the graph? As x approaches negative infinity, what's happening to the graph? That's what I want. So, look at your equation. Okay, I just... What's happening? X gets super, 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 super big. Let's just say x is infinity. Y also, sort of. What do you mean not as large? Infinity. 10 million, a quadrillion, gazillion. What's a quadrillion, gazillion plus 4? Trillion, gazillion. Like, who cares about the 4? Agreed? As x approaches infinity, infinity minus 3. Well, that's a good question. So you have this super huge number. Yes, Sammy. Does y approach 1? How would it approach 3? Sammy, why do you say it approaches 1? As x and the negative 3, they're pretty insignificant, yes? So, what's x divided by x? 1. There's your horizontal asymptote. You guys stop. As x gets y gets huge. So infinity plus 4 is the 4, who cares? Infinity minus 3. Minus 3, who cares? So they are approaching the same value, which is 1. I'll show you a little bit better. Horizontal asymptotes, you approach. It doesn't matter if it's horizontal or vertical. Horizontal and vertical asymptotes graphs that the lines approach but don't touch. So the parent function, 1 over x. Branches. Draw your branches. They are curves. The one down here, the one on the lower left, what's it look like? Can I cross the horizontal? Can I draw my branch? My asymptote on accident. I just went through the points. Where's the other? Yeah, most likely it's going to be up here. Most likely. How do I know for sure? Plug in a point. Your vertical, you can't plug in 3. Here's my vertical asymptote. To plug in is the right. Why? What's 4 minus 3? Nice and convenient. So 4 plus 4 is 8 over 1. You plug in 4, you get I plugged in 4, I got 8. No, that's good enough. Yeah. What happens when x gets large? They're both approaching the same value because the plus 4 and the minus 3 are totally insignificant. 2 is not a large value of x. If you plug in 2, you get 6 over negative 1. But 2 isn't significant. Plug in 100. 104 over 97, closer to 1. Plug in a million. 1,000,004 over 999,997, it's getting closer and closer and closer to 1. So essentially, as x gets big, the positive 4 and the negative 3 have no effect on the graph. So it's 1. Yeah, Sid. Maybe it's at 6. Maybe it's at 12. No, I'll show you. I'll show you. Sort of. Yeah, Elliot. Let's look. Let's look. Jay. Okay, so I'm getting the same question several times. Let's explore. Y equals 2x minus 3 over x plus 1. Where do you think the horizontal asymptote is going to be? The minus 3 and the plus 1. As x gets large, who cares about the minus 3 and the plus? As y as care about the minus. You end 2. Something about 6, I want to say. 6x over 1, let's say. When x is approaching infinity, does plus 1 really matter? No. Infinity plus 1, who cares? So you're pretty much left with 6. Yes. Let's take a break. In your seat, ready to go at 21. Maybe.